Imagine staring into a mirror that doesn't just reflect light, but time itself. Not your own face, not your present moment, but the infancy of the universe, when existence was still wrapping itself around its very first breath. That's precisely what the James Webb Space Telescope was built to do, to look deeper than anything before it, to peer into the origins of everything. But when Webb turned its golden mirrors toward the abyss, what it found wasn't infancy. It wasn't a cosmic cradle, it was a contradiction, a cosmic impossibility. And what it revealed didn't just surprise astronomers, it shook the very skeleton of modern physics. For decades, scientists believed they had a clear picture of how the universe evolved. First came the Big Bang, then a dark age. Slowly, stars began to form, then galaxies, and eventually life. The further back in time we look, the simpler things should appear, just faint hydrogen clouds and scattered particles. That's what everyone expected Webb to find when it gazed at a supposedly quiet, empty stretch of sky. Instead, staring back from the darkness was something that should not have been there. A galaxy, fully formed. Not a blur or a hazy blob, but a complex rotating system of stars, complete with spiral arms and even a monstrous black hole at its heart. Not just present, thriving, and it wasn't a one-off. As more data streamed, in galaxy after galaxy appeared, all impossibly structured, gravitationally stable, chemically mature. It was as if the cosmic clock had leapt forward billions of years, skipping the slow crawl of evolution and dropping us straight into an era of galactic adulthood. With every new observation, one terrifying question grew louder. What if everything we thought we knew about the beginning is wrong? When Webb first captured an image of one of these galaxies, over 13 billion light-years away, scientists expected little more than a faint smear of ancient light. But instead, they saw architectural elegance, spiral arms wrapped like ribbons of starlight, dense clusters orbiting in harmony, a brilliant core pulsing with energy. This galaxy wasn't forming, it was already formed, and not just barely. It looked like something we'd expect to see billions of years into the universe's history, not just a few 100 million years after the Big Bang. To grasp why this is so baffling, you need to understand how galaxies are supposed to evolve. In the beginning, matter was thin and uneven, slowly pulled together by gravity into clouds that collapsed into stars. Over eons, stars grouped into galaxies. But Webb's images suggested this entire process had already happened far too quickly. That galaxy hadn't just taken shape, it had thrived. The laws of astrophysics didn't allow this. It was like finding a fully grown redwood tree sprouting from freshly planted soil. And it wasn't alone. Webb kept uncovering more. Across vast regions of the sky, multiple galaxies appeared, each showing complexity and maturity that shouldn't have been possible. This wasn't a glitch in the telescope. The instruments worked flawlessly. The problem wasn't the data. The problem was our theories. When astronomers studied the spectral fingerprints of these galaxies, the light that reveals which elements they contain, they were hit with an even greater shock. These galaxies weren't just there. They contained oxygen, carbon, even iron, heavy elements that shouldn't have existed yet because these don't appear out of nowhere. They're forged in the hearts of massive stars and released only after supernova explosions. That process takes time. First-generation stars burn hydrogen and helium, then die, scattering their contents. Later generations are born enriched with heavier elements. That sequence should have taken hundreds of millions, if not billions, of years. Yet here were galaxies, less than 400 million years after the Big Bang, already showing signs of multiple stellar generations. That meant the first stars hadn't just lived and died. The cycle had already repeated, more than once. The early universe wasn't quietly waking up. It was sprinting, forging, burning, exploding, and recycling matter into complexity at a pace no one anticipated. And this raised even deeper questions. Because these weren't just elements for stars. They're the building blocks of planets, atmospheres, and possibly even life. To find them so early was like discovering a thriving coral reef at the base of a volcano that erupted yesterday. The timelines weren't just fast, they were broken. Just when things couldn't get stranger, Webb found something even more outrageous. At the heart of one of these ancient galaxies, sat a supermassive black hole, weighing more than 1 billion suns. In today's universe, that would be astonishing, but in the early universe, it was cosmologically absurd. Black holes are thought to grow slowly, over billions of years, by feeding on gas, dust, and stars. Even the most optimistic growth models can't explain how such a monster could exist within just 400 million years. It would be like finding a fully grown adult who was born an hour ago. And yet, there it was. The evidence was undeniable. The gravitational pull on nearby stars, the warped space, the energy emissions. This black hole hadn't grown. It had arrived. To explain it, scientists are now forced into radical theories, primordial black holes forming directly from dense regions in the early universe, exotic particles or dark matter accelerating growth. But these aren't tweaks to existing models. They're new blueprints for reality. What do you do when every observation breaks the rules? For many cosmologists, the answer is unsettling. You rewrite the rules. Because Webb isn't just showing us anomalies. It's showing us a universe that seems to behave in reverse, where complexity comes before simplicity, where ancient light carries blueprints that shouldn't exist. Some propose dark matter wasn't just a silent backdrop of gravity, but an active architect, scaffolding galaxies faster than we imagined. Others wonder if time itself flowed differently in those first moments, stretched and warped, so that entire epochs passed in what looks to us like mere flashes. And then there's the most chilling idea of all. Maybe complexity isn't the end, point of cosmic evolution. Maybe it was there from the beginning. As data kept coming in, something even stranger appeared. Not in brightness or mass, but in shape. Deep learning algorithms revealed that these galaxies were arranged in repeating mathematical patterns, ratios eerily close to the golden spiral. Webb's images showed a hidden geometry spanning billions of light years, spiral arms, orbital distances, rotational symmetry, all hinting that the universe wasn't chaotic at all, but patterned, almost as if it was coded from the start. Fingerprints. But fingerprints of what? A deeper law of physics, or something far more unsettling, intentionality woven into space-time itself. Then came one of Webb's most controversial discoveries, not a galaxy, not a black hole, but chemical trails drifting through an ancient, interstellar void thought to be empty. The telescope's instruments detected complex organic molecules, not just methane or ammonia, but polycyclic aromatic hydrocarbons, the very precursors to amino acids, and by extension, life. They weren't attached to planets, they weren't inside stars, they were just there, floating intact for 13 billion years, which meant life's ingredients weren't a late arrival. They had been seeded into the cosmos almost from the beginning. If true, life isn't rare. It's a feature of the universe itself. And then came the image that silenced even the skeptics. Webb captured 6 galaxies arranged like petals around a central object, equally spaced, orbiting in near-perfect synchronicity. Scientists called it the flower. No natural model could fully explain its precision. It was an astronomical sculpture frozen in ancient light. Was it a gravitational illusion, a relic of quantum symmetry, or was it something else? A marker meant to be seen only once our eyes were capable of seeing it. Finally, the most unsettling theory of all emerged, that by looking this deeply into the universe, we weren't just observing, we were participating. The observer effect, the idea that the act of measurement changes reality, is well known in quantum physics. But what if it doesn't stop at particles? What if the universe itself responds to attention? Some physicists have noticed patterns in Webb's data that seem to shift depending on how and when they're processed, as if the cosmos is aware of being watched. If true, we didn't just discover ancient galaxies. We woke something up, because what James Webb revealed was never just about stars or dust or black holes. It was about truth, a truth so vast and so intricate that to glimpse it is to feel the scaffolding of reality tremble beneath your feet. We didn't just see the unimaginable, we unlocked it. Galaxies too mature, chemistry too advanced, patterns too perfect, signals too aware. Webb revealed that the universe is not just more mysterious than we imagined. It may be aware of our imagination. Maybe we didn't find the edge of the universe. Maybe we found its memory. And maybe it remembered us. So now the question isn't what did Webb see? The real question is, what saw Webb? If this left you shaken, if the timing feels too perfect, the revelations too synchronized, you're not alone. Keep watching, because the next signal may already be incoming.